Just like to welcome everyone and thank you for taking the time to join us today. We'll be starting in a minute or two, allow people to join and settle in. As a reminder, we'll be making this recording available on demand afterwards in case you want to rewatch or send to colleagues. If you have any questions, feel free to put them in the Q&A chat and we will be happy to answer them at the end. Again, thanks for joining us and we will begin shortly. Okay, go ahead and get started.
All right. Thank you so much. Thanks for joining this evening or this morning on this webinar of Secure Code Warrior on threat modeling with AI. I'm Matias Madou. I'm the CTO and co-founder of Secure Code Warrior, and I'm joined with Chelle Saunders. She will be the star of this evening. She is senior product manager at Secure Code Warrior, working on threat modeling and all our content and a lot more stuff within Secure Code Warrior. So today we would like to talk about threat modeling with AI and maybe how we can turn every developer into a threat modeler. Let's see if we can convince you about that. Ooh. Oh, you're controlling the slides. Anyway, first of all, so threat modeling, you may actually roll into threat modeling because of some need, of some compliance need, because other people say, hey, it's a really good practice, and you actually save time by doing threat modeling by implementing the right type of stuff and doing less rework at the end. And when you roll into threat modeling, well, somebody is going to pitch it to you. Maybe a person that does regular training in your organization that says, hey, you know what, this threat modeling thing is pretty interesting. Or maybe a vendor of a tool that does threat modeling that shows you a rosy picture of threat modeling. So when you roll into threat modeling, you may think 2 years from now, this is going to be a perfect world. This is going to be such a nice world where I do threat modeling. Everybody will be engaged. And this is going to be a very interesting practice for me. Well, reality is maybe if you've ever joined ThreatModCon where people do real threat modeling, it's actually pretty hard. It's non-trivial. It is a field that is in constant development and has some challenges. One of those challenges, if you essentially try to do it with software developers, is, well, it's slow and it's manual. Or maybe we're writing code faster these days and threat modeling is perceived as slow because, you need to do a whole lot of things to do a threat model. And, coding goes fast, especially in the age of AI. So time consuming, it's considered to be slow. Poor enablement. Well, you know what? It's a practice that started with AppSec people, and security champions in your organization may have taken over, but ultimately you also want your developers to do threat modeling. So poor enablement is pretty interesting because guess what? All those three roles are pretty much overworked. They have zero time. And let's be honest, for the developers, they focus on features and functions and not necessarily on security. Last but not least, well, you may say outdated tools or you may say outdated models. Given that we go so fast with software development, the threat model or the design should keep up with the speed of development. So it's a hassle, or it may be perceived as a hassle to constantly update the model so that the threat model is really in line with the code that you are developing. So, threat modeling, then versus now. Of course, today we live in the age of AI. Let's talk a little bit pre-AI, manual documentation and diagrams. Well, threat modeling before AI came around was very manual. We had to create manually diagrams. It lives a little bit outside of the IDE, or it lives actually most of the time outside of the IDE, quite often even on a whiteboard. Not a bad thing, by the way, but it lives outside of the code. And if you're trying to involve software developers, well, it's really hard because each of them knows something about the code, but it's really hard to find the software developer that knows everything about the entire application. Well, today we have the age of AI, and hopefully that can resolve a lot of things. Well, in the age of AI, it actually can help speed up the process, and Shell will try to convince you about that. But in the age of AI, well, if we can make AI help us do a design review, we will write better code from the start. We will write more secure code from the start, and we will do less rework. So before I hand it over to Shell, threat modeling with AI, how can we seamlessly make this flow into the developer workflow? Well, first of all, let's do threat modeling for the developer, making sure that the developer can understand and can help with this particular process. Why am I saying that? Well, it's a practice that started with AppSec. It was not a developer that started to do threat modeling. It were AppSec people that started to do threat modeling and try to push this to developers. Second, hopefully we can learn that we can use safer patterns from the start. We can use more secure patterns from the start and essentially mitigate entire categories of problems. And last but not least, I really like this one, think like an attacker. Quite often people say to the developers, to do threat modeling, just think like an attacker. It is that easy. Well, let me give you an analogy. If I give you all the ingredients to make a fantastic dish and I say to you, think like a professional chef, well, will that then be a perfect dish? An absolutely magnificent dish? I highly doubt it. If you're not skilled in that area, you cannot just simply think like a professional chef or think like an attacker. The interesting part with AI is the fact that AI does have a lot of examples. It does have a lot of examples on how to think like an attacker. And it can use those samples to essentially create something to help you as a software developer. So, last but not least, what can Secure Code Warrior do for you? Well, with Secure Code Warrior, our goal, our mission is to help you as a software developer to be very productive in the age of AI. We would like to make sure that you know how to use AI to create secure code. That means not only creating the code itself, but also doing things like threat modeling, for example. At the same time, we also would like to help the CISO to get some visibility into, the risk in your developer organization. Are we doing better or worse than our peers in the industry? So we would like to create the visibility for the CISOs, making sure that they know what AI practices we're mastering within an organization and what AI practices we can potentially improve on. So with no further ado, I would like to hand it over to you, Shell.
Thank you very much, Matias. And let's jump into the first question, which is a very basic starting question, is why do we want developers to threat model? That's the kind of initial conceit here that everything else flows from. So why is this something we want our developers to do and not just our security folks? Well, the first one I think is pretty straightforward: remediation costs. The earlier we can catch vulnerabilities, the cheaper they are, the more time efficient, the more cost effective they are to remediate. So that's a big one. The next one, another big one, is that our security resources don't scale. We see here from the latest BSIM report, the software security group member to developer ratio across organizations in 2025. That ratio is not great. 7.29 is not terrible, but in terms of being able to threat model more robustly, if it's only your security folks doing it, that just isn't going to scale with the amount of software we're building, and we're building more software with AI code generation. We want our security champions to help, that's great, but also we can see that the ratios there are still not going to keep up with the kind of scale that we're talking about wanting to get out of threat modeling. So that's really why we need our developers, why we want our developers to start becoming proficient and do more threat modeling in their day-to-day. And of course, there's also secure by design. This is, there's a big push in this. There's a lot of organizations talking about secure by design, a lot of standards, CRA, NIST2, a lot of these places are really focused on secure by design and trying to push that as an idea to get more secure software out in the wild. Now, the real question is, we've been talking about this since at least 2011, if you look at the literature. This is a sample paper, and this is often cited in even very modern papers about this topic. And then the question becomes, why aren't developers threat modeling? If we've been talking about this and trying to get them to do it for over 10 years, what are the blockers? So let's start by just narrowing down the pool of problems and talk about what the problem isn't. Firstly, it's not about tools. There's a lot of tools out there ranging from enterprise grade options to open source community-driven options at basically any price point you might want. And the problem with the tools from a developer perspective is that the tools are always built by security people for security people. There's not really tools that are built by developers for developers. We have some attempts of security folks to build for developers, but all of those tools really end up missing the mark. It's also not a problem of frameworks. We've got a dozen or more major distinct frameworks and methodologies, and if you include the niche options, we've got even more of them. So it's not a problem of we're missing a framework or we're missing a pattern that we need to follow to help us think through how to catch some of these vulnerabilities in threat modeling. Let's think about the negative feedback loop that we are seeing when we get developers, or when we try to get developers to threat model, because this is the common pattern we've been seeing since 2011 in the literature and in the research. So the first problem is speed. Diagrams take a long time to build. It's hard to even know if you've got the right level of detail in your diagram. It's very possible to bring a diagram that's pitched at the wrong level, super time consuming. The sessions themselves can be very time consuming, very long. And then out the other side, figuring out what to do with the output is also very frustrating because oftentimes the output isn't great. Then we have a lack of expertise. Matthias mentioned thinking like an attacker is not something that comes naturally to people. It is a skill set. And developers aren't intrinsically good at that idea. Additionally, there's a lot of back and forth around, do we have the right people in the room? Do the security folks in the room understand the system? So it also ends up spending a lot of time talking about how does this work? Is this exactly how it works? What do you mean by that? There's a lot of back and forth as these two different teams try and understand each other. And then there's this perception of very low value, especially from the developer side. And this quite often gets driven by not high quality output, not actionable output from a developer perspective. They often end up getting a list of very abstract security jargon filled to-dos that don't really translate to code to systems in a way that they understand. And that then takes longer. So it feels like a waste of time. It just makes everything more drawn out. And over time, as we do this a few times, we see this increasing negative feedback loop and negative thoughts around the idea of threat modeling. So let's dig into a little bit of these three ideas. Threat modeling being slow. A big part of that is that it's out of sync with modern business and Agile values. Agile in particular, part of its value is working code and features over documentation. It's not intrinsic in Agile to build a lot of documentation because things are changing so quickly and design becomes emergent. There's also a lot of questions of what level of detail is correct. Do you have the right people in the room to even discuss the topics you're discussing? It's really time consuming, and it's not just the session themselves. There's a lot of prep before that somebody has to do, usually a couple of people working together. And then it's really time intensive after the session. quite often those pre and post session activities are the most time intensive and draining. And this disproportionately ends up falling on seniors and champions who are kind of the only people who have been cross-trained well enough in security to try and figure out what to do with the output. And that causes a lot of slowdown. It also causes scale problems. I spoke before about getting everyone in sync, lots of questions of how does this actually work? What's changed since the last time we threat modeled this system? What are the new features? Have we made any changes to these microservices? What's the configuration? All of those things need to be worked out, and those can suck up a lot of time from the session, just getting everyone on the same page, leaving even less time to do the actual threat modeling. And of course, it's often out of date before it's done. There's a lot of documentation drift once you've built out these diagrams, and then they get drawered and not touched until the next threat modeling session. Again, agile software design is emergent, and if you're pushing code to production all the time, maybe multiple times a day, which is very common, it's often out of date before you're even done the session. Also want to talk about the expertise needed in threat modeling, and I think the best way to do that is to talk about our AI challenge. When we were first prototyping this, we made a very early prototype and put it in front of a bunch of developers, junior devs, senior devs, mid-level security champion devs, and they really had a problem with this part. That's the identifying the specific security jargon that labels the threat. Most of them were able to correctly find the problem in the code, especially the seniors and the security champions. Most of them were also able to, in their own words, explain what the impact was, what might go wrong if that code was allowed to stand. And they were all able to tell me how to fix it. But every single one of them really struggled with the security jargon of identifying the high-level category that that vulnerability fell into. And so we translated that into the final AI challenge. We moved away from an identification step and into an impact step, which we found more useful for developers. We speak to them more in their language and give them something that is more easy for them to understand and is more appropriate for what it is they're trying to do in their day-to-day. And I think this is a really important example because we should remember that security jargon does not equal developer jargon. It's very easy to forget this. A really great example is in the security world. We think of something like a SAST scanner. To a developer, that's probably more akin to something like a security linter. Same kind of idea, they kind of pick that up, but that immediately speaks to them on what that is. The other part is that builders don't intuitively know how to be breakers. That is a particular kind of mindset, a particular kind of training and experience and a way of thinking that developers just don't build in their career path. They don't build it as a matter of course in their day-to-day. They actually think very differently about the systems they're building. I think the other important one is that when we speak in security about what can go wrong, we think of that question as being very general, but actually that question is really hyper-specific. What we mean by that question actually is how can a particular kind of person with malicious intent use this in unexpected ways? Developers think about what can go wrong all the time, just not security things about what can go wrong. They have to do error handling, they have to catch edge cases. This is a very specific kind of what can go wrong that they're just not trained to think about and don't have a lot of information or training in. Which means that if you send developers off to do their own threat modeling, we're often sending them into a desert without the right kind of preparation, without the right kind of skills, without the right kind of kit. I want to talk a little bit about unactionable output, that value piece from a developer's perspective. Quite often when we want developers to do threat modeling, we hear the speed and expertise problems, and then we solve for that by trying to use automated threat generation libraries. And that compounds this problem of unactionable output because what we get out the other side is reports that look like this, very jargon-filled, extremely abstract, very difficult for a developer with no security or very little security expertise to understand and no connection to their code. What they're getting is a lot of pieces without a coherent picture. What are these things? How do they relate to my code? How do they relate to my systems? What are the false positives in here? Before any code-based remediation can start, there is still a lot of work to do. So let's talk a bit about LLMs. I want to start by talking about how security researchers are using LLMs because that will help us understand, is there anything here? We do see that there's a lot of security researchers using them in POC generation. Brainstorming is a big one. We got 67% of security researchers using them in their work. When asked where they think AI will have the most positive impact, 45% of them actually identify threat modeling as the most promising in the area with most potential. And yet, when surveyed, only 7% of companies are using LLMs regularly in threat modeling, and maybe 15 to 20% say they might be using them occasionally. This feels like a real lost opportunity here. If security researchers are using LLMs to help them brainstorm and figure out what possible vulnerabilities are, or attack vectors, there isn't a reason why developers couldn't do the same thing. If we think about developer usage with LLMs, there's a lot of alignment here. They're using it a lot to search for answers, to learn new concepts and technology. They're already using this for this kind of brainstorming, learning, research work. Also, LLMs are increasingly in developer IDEs where they can get hands-on all the time. They're getting very proficient with these tools. There's also these ideas of spec-driven development rising out of the use of AI code generation to help developers write code faster, but also keep that code generation on better rails. And these are text-based documents that developers write or have the LLM help write as part of the planning phase with them, which can be used for threat modeling. They're really context-rich. Of course, you can deep dive into specific context as you need it, as much or as little as you need. And there's built-in jargon translation. You can have and prompt the AI to think about security, but to comment and tell you about it more in developer lingo. So looking at all of this and doing our internal research as well as our external research, we built out a topic around threat modeling with AI to help developers think about how they can use the AI in their IDEs to help them become better threat models and do threat modeling on every feature. We talk about threat modeling at design time, a code review, some advanced techniques, as well as some sample prompts and demos to get folks started. And speaking of demos, I know everybody likes a good demo, so let's get that going. One moment while I switch over to another screen. All right, the first thing I'm going to do, because AI can take a little bit of time depending on how much code it's going to look at, is I'm going to get that going and we're going to come back to talk about exactly what it's doing in a second. So this is a Java code base. It is a code base that is around an expense tracker, a small little app that we built for this demo. And you can see there's some code in here. We're going to close that. One of the set of docs that we've got some very basic docs. The first is application requirements. So these are some high-level existing feature requirements that that are relevant for this app. So what is the base state that this app has? Just some very basic text-based requirements. The other thing we have is a set of feature requirements. This is a new feature we are looking to build and add in, augment the functionality in here with this receipt photo upload tool. We're in a design stage. This hasn't been added yet. It's something we want to add. And so we've got a set of user stories, functional requirements, technical requirements, some stuff that we've potentially already talked about or been handed by a product manager. We also have here some existing information about the baseline security requirements that this app has to help the AI understand at a very basic level, what's the current state of the security of this system? How does it work? What kind of requirements are already in play for it to think about as it's running its analysis? So those are the docs that we're feeding into it. Let's look at the prompt that I fed in. And we can see here, this is probably the longest prompt that I've got, and all of these are available as samples in the topic that we've made available on the platform. This one has been edited a little bit because I'm using VS Code and I'm using Klein and I'm using a very particular model. And that means sometimes you have to do a little bit of tweaking. Mostly what I've done here is just tweak to ask it for more specific output that I'm looking for. Tweak it to make sure that it's being a little bit more verbose than Klein is inclined to be based on his system prompts. But what's really important here is that I'm feeding it some system context. I'm telling it who it is, a security expert that's collaborating with a developer who needs to translate some security concepts into developer terminology. And the task I'm giving it is effectively a threat modeling task. Think like an attacker, analyzing this new feature and how it interacts with the existing system. And you can see, not quite yet, but you will start to see it pulling code as well. So it is going to start to look at code as it goes through. We pop that back open again while it's writing. And we've basically just given it some guidance on the kind of information we're looking for and how verbose and accessible we want that information to be. And we've asked it, there's some specific things that we want it to pay special attention to. And then we're also reiterating that we want to make sure that these security concepts and jargon are provided in terms that a developer would understand. We want to focus on realistic attacks rather than something abstract. So that's the prompt it was given. That's what it's running currently, and it's working on writing up that report for us. Of course, LLMs are always going to give you something a little bit different. So we'll see what we get out the other side here. As you're building out your prompts, you can be much more prescriptive with the kind of information you want it to provide back to you in the formatting. That's one of the nicest parts about this kind of approach is you can build out over time your preferred default prompts that match your needs as a business, that match your team's needs, that match the developer's needs to create these kinds of artifacts. So it's just running through. While it does that, let's take a quick look at a follow-up prompt we could ask for once we've got that analysis done. And this is what we call our deep dive prompt. And it is really about taking that analysis and saying, there's something in here I want to know more about. I really want to target my understanding to better understand something about this. That's come through in this analysis. And so this is, again, just focus on this vulnerability that you've called out, this possible threat, and give me a lot more detail, in particular things like coding patterns to avoid, the simplest way to prevent it in Java. Okay, I think it's just about done here. Let's put that into preview mode, make it a little bit more readable. So we can see here we've got our threat analysis that it's put out for us. It's given us a little bit of summary, and it's given us some information about data flows and suggested trust boundaries. And then it's also going to start calling out some threats it sees. So the first one it's noted is unauthorized access to other users' receipts, which is an IDOR, but it's also given it to me in very straightforward developers terms, not just something like IDOR, which I might not understand. And it's also starting to use the coding patterns that it sees in my system. And it's talking very much in developer language about what I can do and what I need to look for. You can also see a malicious file upload, talking about, probably going to talk about magic bytes down here. If this is something that I'm not as familiar with, maybe this is the first time I've been confronted with the idea of polyglot files of magic bytes. That's a great candidate for me to do a deep dive on. And we can just put a reference to that output in here. And then we can run a secondary report and let that run to get that deep dive, and it'll add that to our increasing list of threat modeling docs. We also have some prompt examples here of how you can turn that analysis to requirements. So you can have it translate that into a list of very specific security requirements for you. And if you want it to help you start building tests, you can also have it convert some of those requirements into something like Gherkin BDD scenarios that you can use to start driving your automated testing. All of this will need to be reviewed, of course, but the review is made a lot easier when the information is much more readable to a developer and much more verbose. And then you can go in and update these text files. If you know right away that this isn't a problem, you can remove it from the list. Very easy to delete the information rather than to try and brainstorm new stuff. So that's a quick rundown of a quick demo of the kinds of things you can use AI for right in your IDE. Pop the slideshow back up. Great. So what I want to talk about next is just a couple of notes about what threat modeling with AI isn't. So this is not what it's trying to do. We're not trying to automate something here. What we're really focused on is making threat modeling efficient, usable, and valuable for a developer. Trying to really center the developer in order to make this work for them as best as possible. We want to pull all of those great ideas threat modeling has and bake it into the developer's day-to-day, into their existing processes, their existing flows, their existing tools, bring them that security specialist right in their IDE and make it something that they can do in small bits all the time, regularly with every feature, and make it something that's much easier to action because it's right there in their code, it's referencing their code, it's helping them understand how they can make these mitigations right at the code level. It's also not a replacement for standard threat modeling practices. Those still have value. Think about this as a new layer of that security onion. It's designed to complement existing cross-team threat modeling and rapid risk assessment practices. The idea is to threat model every feature and every change, because if you could introduce that into the habits of developers and their agile practices, you're going to get a lot more coverage early on in that design phase, rather than having to get the code written and then remediate afterwards. It's always important to remember here that AI is a place to start and should not be the final word. It's not the place you want to finish a threat model, it's a place you want to start it. And that LLMs should really not make final decisions about risk. It just doesn't have enough context around the business, around the risk appetite of the business, which is always unique to all the specifics. It might give you some guidance around overall sort of industry thoughts about the risk, but the business always really needs to make those final decisions. There's a few little bonuses that you get by threat modeling with AI. From a developer standpoint, it's a learn by doing. It really reinforces and brings alive what developers are learning on Secure Code Warrior by putting it into daily practice in their day-to-day work. We're building breaker mindsets through that repeated value-driven exposure and that they will bring that to the formal threat modeling when they attend those sessions. They'll have some more experience on what it means to think like an attacker, because they'll have more experience sort of thinking about their code in a new way by reading through the output that these LLMs provide, where the LLMs are taking these abstract scenarios and creating specific variants of those highly related to their code base. These processes are also customizable and highly personalizable. Different developers can tailor it to their experience and needs, but also security teams and security champions can work with developers to create opinionated starting prompts and IDE AI assistant modes to streamline and align use. So if there's specific kinds of frameworks that you want to use for specific kinds of security tasks, or maybe you've got very specific middleware or services that you want people to use for specific kinds of tasks, you can start to build those into standard chat modes that are really aligned around this kind of threat modeling approach. The other benefit here is we can start to iterate these security artifacts, which are captured in text with the code bases. They're very readable, they're developer first, they're baked into the code, and they can be iterated and reviewed with code. It's just text, which means that it makes great diffs in Git. Useful again for rapid risk assessment and informal threat modeling sessions to have those artifacts in front of you just to understand what's been done or what's been considered. And they also make useful rails for AI code generation as devs start to use more AI in their IDEs to write more code for them. So let's take a look at that negative feedback loop we talked about before, and let's see how this changes that loop, hopefully for the better. So first, we're going to threat model every feature while it's being built, while it's being designed. We're going to try and bake it into daily flow, into the developer's tools. They don't have to context switch. If they're thinking about design, if they're already thinking about how they're going to work with the code to implement this new feature at the beginning of the process, this is a part of that existing practice that they're already doing. From an expertise standpoint, we're not using security jargon. We're very focused on developer jargon and doing that translation. We're allowing the developers to speak their own language while they're thinking like an attackers and thinking about all of the security implications of their code. And over time, they're going to find that they're better able to do that core skill. That skill is going to increase the more and more they do it. And there will be more value here for the developers because the information they're getting back is going to have immediate actions in code and in context. It's not abstract. It's not something they have to sort of scratch their heads about and figure out if it applies or not. Working with the AI, they're able to figure out quite quickly, does it apply in my very specific use case? And if so, how do I mitigate it? And quite often the LLM will produce really nuanced, really specific mitigations. And a bonus from a speed perspective is that security documentation, if we keep it around, if we iterate it with the code, it's going to drive collaboration and code generation with AI, which is really, really useful from a dev perspective, because the faster they can move, generally speaking, the happier devs and the business are. And if we can make them fast, but also make them more secure, then really everybody's happy. So if you're looking to learn more about how to incorporate threat modeling with AI into your developer workflow, you can find all our AI and LLM and threat modeling content on demand in Learn and Explore. And you can also ask your Secure Code Warrior admin to add the threat modeling with AI quest.
Thank you, Chelle. That was very brave to go with the demo.
You never know what an AI is going to do in a demo.
No, very brave. All right. Any questions that came in?
Yes, there were. First one, has adoption been tested with any teams using this approach? Were there any roadblocks?
We haven't had, I haven't heard of anyone adopting it as a full team, but I have had a series of conversations with developers who are adopting approaches like this, some of them based on our suggestion, and some of them very organically on their own, just starting to emerge the more they've worked with these LLMs in their IDEs, and they're finding them really, really useful. In fact, one of the devs I talked to actually called out unprompted that he thought that he was becoming a much better threat modeler because of the way he was using AI and LLMs in his IDE to ask questions. He started asking really general questions about how to make his code more secure, or if the code needed some more security considerations, because he didn't have really robust knowledge about what security things might apply to the specific code he was writing. But as he went through basically the analysis from those general questions, he over time has found himself asking much more targeted questions, because that natural developer instinct to optimize their time, to optimize their token use with AI code generation, he was really starting to just internalize a lot more of that information and a lot more of that security approach over time, just by exposure, and especially that really useful exposure to the precise task that he was working on. Developers will always tell you that they learn best by doing.
I like the question a lot because threat modeling is slow, as I've mentioned in the beginning. And if I look at real adoption of threat modeling, it's super slow, if I can say that. Like to roll it out enterprise wide, it takes years. And this is new, this is novel. So, what I've seen with you, Chelle, and with the teams, it's actually a quite rapid adoption, if I can say that, within teams. So, they're trying it out, they're trying to figure out, but it's not like it's not a massive rollout within 2 months. You cannot expect that from tools like this. But I see it as going faster based on what I know from what I've seen back in the day with tools and how enterprises roll this out. I think this is going faster than what I've seen back in the day. But it's a really good question because adoption is really, really hard, because the normal philosophy is, well, you need to train and you need to upskill, and then you go to the next team, you need to train, you need to upskill. And this type of cycle is a little bit shorter because, well, a lot of the train and upskill is essentially taken over by the AI solution, by the templates, by everything that's in there. So it's more the usage of those templates and the AI solution and potentially the credits than really the upskilling and training part.
Great. Thank you, guys. One more question. You said old tools produce unhelpful generic reports and false positives. How do I know this won't just give me a longer list of AI generated false positives to deal with?
So there are going to be some false positives in here. I think the biggest challenge with traditional threat modeling when it comes to getting developers to do it independently is they end up relying on a lot of super generic libraries. So they make their diagram, spend a lot of time doing that, and then run an analysis based on a generic library, and they get a lot of generic output. And that's very difficult to parse through because it's so abstract and not speaking the developer language. When we're talking about this, it looks like a lot of text, right? We saw the lines, it generated something like 500 lines of text, but it's very scannable text, and you can make it more scannable. You can also tailor that output if you want it to output you something that's more like a list of things, and provide you with less information as a first run, and then spend more time on the deep dive aspect. It is very flexible. It's very easy to scan, but also from a developer standpoint, it's easy to understand. You can read through it, and because it's using aspects of your code, it's using the wording of your feature, it understands the context that it's trying to threat model. It's much easier to follow and figure out where those false negatives are, because you can very quickly go, that doesn't apply to me because of X in a lot of cases, and then just move on, which is very useful. Whereas if you're getting a really large Excel sheet that's got 100 kind of abstract things and just maybe a repo or a service, really hard to even know where to start in those kinds of situations.
Customizing tools is always very hard. And I think with AI, that's going to maybe change. They definitely have a shot at changing it more rapidly. I've seen that back in the day. If you want to make a tool for any scenario, for threat modeling, for static analysis, you want to be able to apply this to a broad code base. So you cannot make this specific to your code base. But actually, you want to customize that. You want to make it very specific to your code base, because then it's more actionable. So that investment takes potentially a lot of time, because back in the day, it was all manual. I think with AI, we do have a shot at getting a more rapid customization cycle, because we can feed it examples of what it looks like, what our stuff looks like, what our code looks like. And I like the question a lot. Because I feel this question comes from pain, from pain back in the day, on how those tools used to give you generic information, generic answers. And the question you may, of course, ask is this going to be just the exact same stuff, only faster? And I think the answer is no. I think we have a really good shot at getting better results here.
I think there's a really good shot at getting better results because it has all that context, but I also think part of the puzzle is making the triage as fast as possible, right? How quickly can you find those false positives and move past them? I think the faster we can make that process, the better off we are as well.
Great. Thanks, everyone, for joining today. Again, this will be made available on demand. You'll be getting an email in the next few days where you can watch it. Thank you, Chelle and Matias, for presenting today.
Thank you so much. Thanks, everybody. Thanks for joining us.
Everyone.
Bye-bye.